Now what we're going to do in this video is blow up an electrolytic capacitor. And before we look at the circuit, we're going to talk a little bit about the construction of electrolytic capacitors. Today, electrolytic capacitors are constructed with scoring on the case or the metal can that goes around the capacitor. And this scoring is done so that if the capacitor fails due to manufacturing defects or excessive voltage or the capacitor being inserted in the circuit incorrectly, that when current flows to the dielectric and it causes a rapid buildup of gas inside the capacitor, it will blow the end of the cap out where the scoring exists, and the explosion won't be quite as violent and it won't blow the case off. Now, it will be really messy because it'll blow paper everywhere inside the piece of equipment, but again, the explosion is not quite as violent. Now, in the electronics lab at Wake Tech, we've got some old capacitors, and you note with this capacitor there's no scoring on the end. So if the capacitor malfunctions and explodes, it will actually blow the case off and cause a much more violent explosion, and it is a little bit more fun. But what we see here is a 220 microfarad electrolytic capacitor that has a DC voltage rating of 25 volts. And note that on the marking of the capacitor, we can see the arrows inside the arrows that denote the negative terminal. And I have the red lead, the positive lead of the power supply, connected to the negative terminal, and the black lead is the negative terminal of the power supply connected to the positive terminal of the capacitor. And the DMM is connected to the output of the power supply, so we see that the power supply is set to output 25 volts, which is within the stated DC working value of the capacitor. Now, what's going to happen is when I turn the power supply on, you'll see the DMM drops down to about 12 volts. And this is because the power supply in the lab has built-in current limiting, which means that if the power supply is delivering more than 500 milliamps of current, it will drop the output voltage of the power supply down to a level that will limit the current to that 500 milliamps. So again, when I turn the power supply on, we'll see the DMM drop to about 11 or 12 volts because there will be so much current flowing through the dielectric because the capacitor is connected with incorrect polarity. So I've turned the power supply on, and note that the output of the power supply has dropped down to about 11 volts. And we can see that, again, the output of the power supply is increasing and increasing and increasing. And all we're going to do now is wait for the capacitor to explode. Wow. That was pretty exciting, wasn't it? So again, remember when you install capacitors, electrolytic capacitors in circuits, you have to observe the polarity of the capacitor, because we just saw what happens if you connect the capacitor with incorrect polarity.